Okay, let's begin the go through for the 3E combined science paper in 2021. So section A is pretty simple. First, we test you on your content recall. So it is important that you respect the capital letter or small letter. So for example, in this case, mega and gaga are in capital letter, and the spelling for the prefixes must be correct, and we will award 1 mark for every 2 correct answer. Okay, for question 2, you need to know the name of the unit. So for example, A, this is ampere. This is the name. So ampere is actually the name of this unit. But what ampere is measuring? Ampere is actually measuring the current. Okay, so when we say quantity, we are actually checking what quantity are we measuring. Okay, so for example, as the name of the unit is seconds, but the quantity that we are measuring would be time. So that's the difference between name of unit and name of quantity. Okay, for question 2a, there are many possible answers. You can tell me that mass is scalar, weight is a vector. And if you refer to your textbook, there are actually 3 other differences. So you can refer to your textbook for the exact answer. For part B, we are checking whether you are familiar with the differences between mass and the weight. And you can see that it is fine to have no units because the units are actually at the heading. So what you need to know is that for mass, whether you are on Earth or whether you are on Mars, you will have the same magnitude. You will have the same 20 kilogram. Okay. As for the gravitational field, it differs from planet to planet. So for Earth, the gravitational field is actually about 10, and for Mars it is 4. Now when you are asked to find the weight, you need to make use of this formula, W equals to mg, whereby m is the mass in kg. Okay, so it is very important that you have mass in terms of kg. So if you are given the mass in gram, you would need to convert it. And for g, this is actually referring to the gravitational field strength. So when you multiply them together, these are the answers that you will be getting. Okay, so in terms of mark allocation, if you can give me the correct mass of Earth, you will get 1 mark. And for the weight, you need to get both correct in order to get the second mark. There's no half mark. Okay, for question 3, it is not very well answered, especially for 3B. So I will spend more time on 3B. Okay, for 3A, you are actually expected to explain why the thermal energy is loose to the air, meaning that you have to explain why the heat energy is in this direction. So it is in this direction because the water is hot and the air is actually cooler. So you need to tell me that the heat will actually follow the direction because it travels from a region of higher temperature, which in this case is the hot water, to the region of to a region of lower temperature. In this case is the surrounding air. Now for B part 1, if you are unable to get most of its mark, it means that you have not tried out the TYS question. It is from a TYS question. So for part B, you are actually asked to describe how, meaning that you need to tell me the process, whether it is conduction, convection, and of course, if you look at the number of answer line, there are 5 answer line, meaning that you need to really describe the processes involved in great detail. And they already tell you that the energy is lost to the surrounding air. So if you look at B part 1, they are interested in knowing the mechanism involved that is happening inside the metal. So for example, the reason why I choose this as an example script, because here you can see that the question directs you to talk about what is happening inside the metal. But as you can see, this student actually focused a lot on what happens to the water molecule. So even though she has given a lot of details and effort in answering it, but she is actually focused on the wrong medium. So the question requires you to talk about the metal teapot, but you actually talk about what is happening in the water. So because of that, she get very, very little marks. So I hope this experience tells you that sometimes even when you have studied a lot on the content, you still need to pay attention to what the question actually requires of you. If the question wants you to talk about what is happening in the metal, then please make sure you are talking about what is happening in the metal. And actually in the question, they also directed you to talk about the mechanism involved in conduction. So in conduction, there are a few things you need to know. One thing is, of course, if it is metal, it means you need to talk about the free electron diffusion. So for those of you in your answer, you see this word FED, it means that you have not talked about free electron diffusion. Another thing you need to talk about is, of course, the transmission of energy through the collision of neighboring particle. So this is some of the keyword that you would need to have in your answer when you talk about conduction. So for B part 1, if you are unable to score very well, actually what it means is that you are you need to talk about the mechanism in steps. So I have given you a simple diagram here to illustrate what we are going to talk about. So first, we have to talk about what is happening inside this piece of metal. And of course, we are talking about the heat energy traveling from the hot water inside, to the cooler air on the outside. So in your explanation, it should involve 3 main processes, right? 1, 2, and 3. So if you have that in your mind, then it becomes quite straightforward. In your part 1, what you need to do is that you need to be able to identify where does the transfer begin at. So in this case, the metal molecule will gain heat, right? And you need to actually say that nearest to the hot water. So maybe you have to identify that this metal molecule that is gaining heat, so this metal molecule should be nearest to the hot water. So you need to identify where does this entire process start, because anyway you are describing a process. So when you describe a process, you need to talk about the beginning of the process, right? So it begins at the metal nearest to the hot water. Will gain heat, and in this case we must identify first, right? Because that is the start of the process. Okay, so the metal molecule nearest to the hot water will gain heat first, and then you need to tell me that what will happen next, that it will vibrate more vigorously. Then in part 2, you need to talk about what happens next. So in part 2, you need to tell me that, oh, this energetic molecule will collide with its neighboring molecule. It is not just any other molecule. Some of you forget this very important adjective, neighboring. You need to have that, okay? Because it highlights to you the main mechanism of conduction, which is to pass on the energy by knocking into the neighbors, right? And for number 3, because actually I won't call this number 3, I would rather call this 2B, and then this I would call it 2A. Yeah, because for metal, conduction actually happens simultaneously in 2 processes. One is the conventional way whereby you pass the energy to your neighbor. The second way that is special for metal is that because metal has free electron, this process, free electron diffusion, will also happen. So in this case, you don't have enough answer line to really elaborate on what is free electron diffusion, but you can mention the process. This will allow your marker to actually understand that, hey, actually this person knows that this will happen, okay? And of course, step 4 is the final conclusion that these processes, what is these processes means? This means that your process 2A and your process 2B, okay? And I forgot processes. So these processes will repeat, and the heat is transferred through the metal and lost to the air. So overall, for your B part 1, this is your answer, okay? And it is quite a lot. So in order for you to memorize it, you need a certain system lah. So this is what I suggest you to do, to visualize it in a pictorial form. Okay, for the next part, you are asked to actually talk about how thermal energy is lost to the surrounding by convection. So basically what happens is that this is what you should picture, that the hot water is losing air to the surrounding through this convection current which is rising. So it is important for you to actually identify, like I said again, that the air, don't forget to highlight the beginning of the process, right? It is the air nearest to the kettle, right? This is the air that will get heated up first. right? So the air nearest to the kettle will gain heat from the kettle. And of course, the most immediate effect, you can tell me that the volume expand and whatsoever, but the rising effect comes from the drop in density. So you need to tell me the key, the change in the density. So what will happen next is that this air, after it gains the heat from the kettle, it will get warm up and the density lower and it will rise. And as it rise, it will actually carry the heat away. So actually you just need to tell me how this warm air would rise and how the heat will be carried away by convection. In fact, you don't really need to talk about the cool air replaces it and the conventional current forms. Why? Because if you are telling me that, oh, okay, it rises and then after that, after some time, the air will cool and come back down, you are actually explaining to me why the surrounding air will get heated up evenly. But our focus in the question is actually how heat is lost from the kettle to the surrounding air. So we should focus on that, and anyway we only have like 3 answer line. So we should actually focus on how this thermal energy is lost to the air through the rising convection current. You don't even need to talk about how the other cooler air would replace it and get heated evenly. Yeah. Okay, then of course, you have to then we in part C we are actually checking whether you have studied radiation, and actually to slow down the rate of energy loss through radiation, you should use white color or silvery color. Okay, and for texture, I think in the end, did we accept shiny? I think texture we are looking at things like rough, right, or smooth, or you can say the surface is polished. So I think in this case I make a marking error, it will be deducted. Okay, so this will get -1. Unfortunately, I will change it on the actual script. So to slow down the rate of energy loss through radiation, you should use a smooth texture. So shiny is actually a color, I would say, but the texture is like rough, smooth, polished, things like that. Okay, now for part D, you are actually asked to identify the difference between boiling and evaporation. Again, that in the textbook there's a table listing out all the differences, so you can refer to it. Like for example, in this case, why I mark her wrong, boiling has a high boiling point. This is absolutely false. It shows that the students has oversimplified what she is about to learn, because what is the boiling point of liquid nitrogen? So if you look at liquid nitrogen, it actually boils at -200 plus degrees Celsius. It is not a very high boiling point. In fact, it is a very low boiling point. So it shows to me that this student has only think about water, and to her 100 is a big number. It is not. Yeah, it is not. So you shouldn't be over generalizing and oversimplifying, or you are just focusing on just one substance whenever you are comparing processes. We are looking at processes, not a substance. Okay. And here you can see that the students is at this point is actually pretty confused. Melting point, unless you have a substance, if not you won't have melting point. So when she say evaporation has a melting point, it is just she has lost it. Either she has become too nervous, or that she didn't really study that chapter. So it highlighted that the student in this case have not prepared properly. Okay, he or she should make notes of the key tables in the textbook. Yeah. Okay, for 4A, I'm pretty happy about her. You can see that there's a very clear and neat presentation. I can see how she thinks. She has used the right formula, right? And she have identified that what this number is about. And you can see that she used the full form, so there's no triangulation error. She even highlighted, even for a simple summation, there is very clear steps on how she acquired the number. Again, you can see how she acquired the volume of copper and how she find the total volume. And after that, she used average density, which is total mass divided by total volume. Very, very nicely presented. So when I look at this and I look at what she did on top, I can only say that this student did prepare, but it seems that during the exam she got nervous and make the mistakes. Okay, for part B, unfortunately, again, you can see that this student is strong in her mathematics, but when it comes to content or conceptualization, she is not very strong. So in this case, I have mentioned a lot of time when you talk about density. Density is what we call a unique property of matter. So what do you mean by unique property of matter? It means that that value is like a signature of that particular substance. So even if you go and cut it into smaller pieces or you lump them into big pieces, the density will not change. Okay, it will not change, and you can try it with dummy value and you can prove it mathematically. Okay, I suggest you try it on your own. Okay, density does not change. So similarly, even if you melt it and then after that you mix it up and all that, as long as the percentage of the mixing is the same, the density stays the same. So the alloy will be the same. Okay, now so how will density change? Well, since you know that solid is incompressible and density is about how much matter you can compact in a certain volume, since solid is incompressible, what does this tell you? That the density of solid more or less stays constant unless you change its temperature. Why? Because for example, you have a piece of solid, let's say it has 4 molecules inside, it occupied this amount of volume. After you heat it up, well, maybe the space between the molecule will be bigger because the volume expand. So here you can see that I would have 4 gram per maybe 10 cm cube. Now that it have expand, it is still the same 4 gram because there are only 4 molecules inside, still just dummy values. And maybe now the volume has expanded 10 times. So by heating it up or by cooling it down, the density of a solid could change. Okay, but very, very little, by a very small amount. Okay.